Hi, it's Ms. Parrott, and this video is about stoichiometry. Stoichiometry sounds like pretty high intensity, but it's really not that bad. In chemistry, we use it to figure out the relationship of the relative quantities of substances in a reaction. That sounds like a lot of words, but it's really not, right? Relative quantities. Quantities, that's just how much. And so you're just figuring out how much there are of different substances relative or compared to the others. So if this is a reaction, right here we have sodium plus water will yield sodium hydroxide and hydrogen gas. We're just trying to figure out maybe like if I have a certain amount of sodium, how much water do I need to make these products? Or if I have a certain amount of water, how much hydrogen gas can I make? Right, so you're just looking at relative quantities within this reaction. The skills you're going to need to be able to do stoichiometry problems are balancing equations and the ability to do unit conversion problems with moles. Let's look at an example. The kinds of questions that stoichiometry can answer are ones like this. How many moles of water are needed to react completely with 3 moles of sodium, right? So we're looking at relative quantities of substances in a reaction. It's really simple, actually, to get there. So let's take a look. The first thing that you're going to need to be able to do is balance the equation. And then you will rock this roadmap. This will also be given to you on paper. Rock this roadmap and able to answer your question. So, first thing, balance our equation. Let's look down here. So I've got sodium and water will yield sodium hydroxide and hydrogen gas. Things are looking really good except for my hydrogens aren't balanced over here. I've got 3 hydrogens all over here and 2 over here. So one easy way to do that is if I put a 2 here, now I have 4 hydrogens, and I can just put a 2 right there, and now I have 4 hydrogens on my reactant side. But now I have, now I have 2 O's, awesome, but I have 2 sodiums over here, so I need to put a 2 right there. Equation balanced. All right, now we look at our roadmap. So we have lots of things you can do with substance A, and then the changes you need to do to figure out substance B. So balance the equation. Figure out what compounds or substances in the equation are substance A and B. And then, say you're given grams, you can use molar mass to figure out the moles, or if you're given moles, you can use molar mass to figure out the grams of substance A. But the reason why it's important to balance the equation is if you're trying to figure out something about moles of substance A to moles of substance B, that's when you have to use the coefficients from your balanced equation. So in this case, right, our moles are the coefficients from the equation with sodium is 2, and with water also 2. Since molar mass figures into the roadmap, I just went ahead and figured out the molar mass of each of the substances in the equation. So sodium is 23, water is 18, sodium hydroxide is 40, and H2, hydrogen gas, is 2. So let's use this, right? Step 1, balance the equation. Step 2, identify your substances and rock the roadmap. Let's do that to answer the question we just showed. All right, so how many moles of water are needed to react completely with 3.0 moles of sodium? So balance the equation. We just did that, but we're going to do it again. All right, then identify your substances so that you can rock the roadmap. Okay, so substance A is what we're given, right? And so I'm given sodium, so this will be substance A. And then water is what I'm trying to figure stuff out about. That'll be substance B. All right, so I set up, I'm going to use train track method. You can use whatever unit conversion method you've used, but train tracks are easy for me. All right. So if I'm given 3.0 moles of sodium, yes, it matters that you put sodium there because we're going to start throwing in other substances. So you got to be careful. All right, over 1. And then we use the coefficients from our balanced equation. So I'm going to have 2 moles of sodium, right? I put it here so that moles of sodium cancel out. So for every 2 moles of sodium, I'm going to have 2 moles of water. And so this crosses out. I was wondering how many moles of water, and so my units left are moles of water. Perfect, which means all I have to do is multiply across and then divide. So 3 times 2, 6.0 moles of water. We got to do the bottom 2. We divide by 2. It gives us 3.0 moles of water are needed to completely react 3.0 moles of sodium. That's a pretty simple one. Now let's look at a little bit harder example. All right, same equation. How many grams of sodium hydroxide are formed with 3 moles of sodium? So this time we're trying to find the grams of a substance, and this substance is a product, not a reactant. All right, so first thing I do, balance the equation. We've done this one before, so we can just write that in. Identify substances A and B. All right, so I'm given this. So again, sodium will be A, and this time sodium hydroxide will be B. Don't forget, we're trying to find the grams. Always begin, just like every unit conversion problem ever, with what you're given. So we're given 3.0 moles of sodium, and just like my roadmap said, now I'm going to use the coefficients from the balanced equation and put that in my train tracks. So I have 2 moles of sodium in here, and then my other substance is NaOH, that's substance B, and according to my balanced equation, I'm also going to have 2 moles of that. So 2 moles of NaOH. Awesome. Now, my question doesn't ask for moles though, right? My question asks how many grams. So now I'm going to have to use the molar mass to figure out how many grams. So just like again, we want these cancel, so I'm going to put moles of NaOH down here so that cancels. So in every 1 mole of NaOH, we calculated this earlier, there are 40 grams, right? There you go. My moles will cancel. I'm left with grams of NaOH. Perfect, that's exactly what I want. So now all I need to do is multiply across. So 3 times 2 times 40 is 240. So I'm going to put my answer down here, okay? 240 grams of NaOH divided by what's on the bottom here, which is 2 times 1. We'll just go with 2 on that one, all right? Equals 120 grams of NaOH. That is what is produced. That's how many grams are formed with 3 moles of sodium. So these are just a couple of examples of stoichiometry problems that you can practice. You should try some for yourself.